Biasing of a diode. Biasing, that means whenever we are connecting our diode with some external voltage source, that is called as biasing. When no external voltage is applied to your PN junction diode, it is called as zero bias. Now, based on the battery connection of your diode with the external supply, we can say that we can have two types of biasing, that is forward bias and reverse bias. So whenever we are connecting the positive terminal of your diode with the positive terminal of your battery and negative terminal of the diode is connected with the negative terminal of the battery, this type of connection is called as forward bias connection. Whereas whenever we are connecting the positive terminal of a diode with a negative terminal of the battery and negative terminal of the diode is connected with the positive terminal of the battery, and this type of connection is called as reverse bias connection. Whenever we are connecting our diode in a forward bias, a large amount of current will flow through it. Whereas whenever your PN junction diode is connected in the reverse bias, it will not allow the current to flow. Now we are going to see how your diode will act or how your diode will work whenever we are connecting in forward and reverse bias in detail. Starting with the first type of biasing, that is forward bias. Here you can see that I have shown two diagrams. First one, that is your before biasing, and this one, the second one, that is after forward bias. Initially you can see that the positive terminal of the battery is connected to the P type and negative terminal of the battery is connected with your N terminal of the diode. Now, as you know that in P types we are having majority carriers will be holes, whereas in N type the majority carriers will be electrons. As the positive terminal is connected with the P side and P side has majority carrier holes which are also positive charge. This positive terminal of the battery and the holes which are present in the P type will be repelled by each other, right? Because positive charge will repel each other. Similarly, the electrons which are present in your N side, the electrons which are present in your N side and the negative terminal, that will be repelled by each other. So because of this repulsive force, we can see that the depletion layer, this depletion layer, which is between your P and N, because of this hole and electrons are repelled because of the external supply, it will be entering into your depletion layer and it will recombine with your holes and electrons. Because of this, the width of the depletion layer, in the second diagram you can see that the width of the depletion layer is decreased, right? You can see that the width of the depletion layer is decreased over here, or we can say it's reduced, and also the potential barrier between your junction gets reduced. And because of this, we can see that a large amount of current can easily flow whenever we are connecting our PN junction diode in forward bias. After a certain amount of voltage, we can also say that the depletion layer will be completely eliminated and it will allow a huge current to flow through it. This was about your forward biasing. Now, if we talk about reverse bias, as you can see that initially your P terminal is connected to the negative of your battery and your N terminal of the diode is connected to the positive of the battery. As this is a negative terminal and as we are having a majority charge carrier in P will be holes, all your majority charge carrier, that is holes, are attracted by the positive terminal of the voltage source, and similarly on the N side the electrons are attracted due to the positive terminal of your battery. Thus, the majority charge carriers are drawn away from the junction, and thus you can see that the width of the depletion layer in before and after reverse biasing, you can see that the width of the depletion layer is increased, right? As the width of the depletion layer increases, we can see that no current flows due to majority charge carriers. So we can say in reverse bias, it will not allow the current to flow. But there are some minority charge carrier which will be flowing from P to N type, and this is called as your reverse saturation current. So in reverse bias condition, we'll be having a very small amount of current, and that is because of your minority charge carrier, and it is called as your reverse saturation current. Now, if we see the difference between your forward bias and reverse bias, it can be uh, done with the following parameters. The first parameter, that is the definition, or we can say how we are connecting our diode in forward bias and reverse bias. So we can see that whenever we are connecting the positive terminal of the battery to the P region and negative terminal of the battery to the N region of our PN junction diode, that is called as forward bias, whereas whenever we are connecting the region of our PN junction diode to the negative terminal and N region which is connected to the positive terminal of the battery, that type of connection is called as reverse bias. The second parameter that we can discuss is about potential barrier. As we have seen that as the width of the depletion layer decreases, we can also say that the strength of the potential barrier also decreases in your forward bias, and because of which the current can easily move across the junction. Whereas in reverse bias, the strength of the potential barrier increases and it will obstruct the flow of charge carrier. The next term, that is our depletion layer. In forward bias, we are having a very thin depletion layer, whereas in reverse bias, the depletion layer width increases, or we can see that we are having very thick depletion layer. The next term, that is next parameter, that is resistance. In forward bias, the resistance decreases, whereas in reverse bias, the resistance increases. Forward bias allows the current to flow through it, whereas reverse bias will prevent the current to flow through it. We are having a very large amount of forward current in forward bias, whereas in reverse bias, a small forward current, that is because of your minority charge carriers. We can say that forward bias operate as a conductor, whereas reverse bias operate as an insulator. Lastly, we can show the circuit connection of your forward bias and reverse bias. Here you can see that the positive terminal of your diode is connected to the positive terminal of the battery, whereas the negative terminal of the diode is connected to the negative terminal of your battery. And you can also see that in this diagram of the forward bias, the current is flowing, which is shown by arrow I. Whereas in reverse bias, the positive terminal of your diode is connected to the negative terminal of the battery, and negative terminal of the diode is connected to the positive of the terminal of the battery. And here no current flows. That's why we haven't shown any flow of current in this circuit connection. So this was about your forward and reverse biasing of your PN junction diode.